Hi everyone, am I audible? Is the audio clear? Okay, then let's start. So today we will study combinatorics. So what is this combinatorics? This is a field of mathematics which is related to counting. So mostly what we do, we count things. Okay, how many ways are there? How many strings are there? How many words are there? So these kind of things. Okay, so this is a very important field actually. Okay, in all the subjects, whether it is discrete mathematics or any other subject of computer science or any other field. Okay, so this subject is very important, combinatorics. Okay, we use this subject in almost at almost every place. Okay, so that's why this is important. And let's start. So the first thing that we will study some basic rules. So we have four basic rules, we will study them. So the first basic rule is product rule. What is this product rule? So this is the, remember, we have four basic rules, and you must you must understand all these four rules, because almost everything you can solve using these rules. Okay, so what is this product rule? This product rule basically says that, let's assume you need to do some task. Okay, I give you some task T. Okay, I give you some task T. Now this to complete this task, okay, let's assume you need to complete the task T1 and you need to complete the task T2. Okay, so basically I am giving you a task, and to complete this task you need to complete the task T1 and you need to complete the task T2. Okay, let's assume that there are n1 ways, there are basically n1 ways to complete this task T1, and let's assume there are n2 ways to complete this task T2. Then how many ways are there to complete this task T? That will be n1 into n2. So this is roughly what this product rule says. Okay, so actually this product rule says like this: you have a task T, and to complete this task you need to complete this and you need to complete this. Now you can complete this task T1 in n1 ways. So there are n1 ways to complete this task T1, and for each of these ways, there are n1 ways. Okay, so like way 1, way 2, way 3 and so on, total n1 ways are there. For each of the ways to solve task T1, you have n2 ways to solve task T2. Okay, then how many ways are there to complete this task T? This will be n1 into n2. So don't worry, we will take examples and we will understand. Let's assume that you want to make a number plate. Let's assume you want to make a password of 4 numbers, let's assume. Okay, so like a pin code, you want to make a pin code. Okay, 4 digit pin code you want to make. Of course, what you can do, so in this pin code, what you can do, this first digit you can put how many ways? 10 ways, because you can put 0, 1, 2, 3, any number you can put here, any digit you can put here. So how many ways are there? 10 ways are there to complete this task. See, your final task is to make 4 digit pin code. This is your task T. Your task T is to make 4 digit pin code. 4 digit pin code. This is your main task. Okay, now what you have done, you have divided this task into 4 tasks. The first task is to make the first digit, the second task is to make the second digit, the third task is to make the third digit, and the fourth task is to make the fourth digit. Okay, so basically this task of making 4-digit pin code you have divided into 4 tasks: first digit, second digit, third digit, and fourth digit. Now, how many ways are there to complete this task? What is this task? This task is basically making the this first digit. Okay, putting the first digit. So how many ways are there? 10 ways are there. You can put 0, you can put 1, and so on. You can put 9. Any number you can put. So how many ways are there? 10 ways are there. Okay, now let's assume that you have done it. Let's assume you have put 0 here. Let's assume you have put 0 here. Now, once you have put 0 here, then tell me how many ways are there to complete this task T2. There are again 10 ways. Why? Because if you have put 0 here, then again you can put 0. So basically, to complete this task T2, again you have 10 ways, because you can again put any number, 0 to 9, any number you can put. So again you have 10 ways. Now let's assume that you have put 5 here. Let's assume you have put 5 here. Now, how many ways are there to complete this task T3? How many ways are there to see? Remember, you are making a pin code. Okay, so in pin code you have this kind of pin code also, like 7789. This is also a pin code, right? ATM pin code. Let's assume you want to make ATM pin code. Okay, so this kind of pin code are also possible. This is also a possible pin code. Okay, this is also a possible pin code. So you can see now how many ways are there to complete this task T3. Again you have 10 ways, because again you can put any digit from 0 to 9. Similarly, how many ways are there to complete this task T4? Again 10 ways. So you can see that your main task is to make a 4-digit pin code, but you have divided this task into 4 tasks: T1, T2, T3, T4. What is T1? T1 is making the first digit. T2 is making the second digit. T3 is making the third digit. So how many ways are there? 10 ways, 10 ways, 10 ways, 10 ways. And remember, to complete this task, you have to complete this task, and you have to complete this task, and you have to complete this task, and you have to complete this task. Basically, you need to put 1 digit here, you need to put 1 digit here, you need to put 1 digit here, and you need to put 1 digit here. So there is AND here. Because of this AND, you will get 10 multiplied by 10 multiplied by 10 multiplied by 10. So this will be your answer, 10 to the power 4. So this is product rule. Product rule basically says that whenever you have this type of situation, this is your main task. And whenever you have this type of situation, that let's assume it can be divided into let's assume T1, T2, T3, T4. Let's assume this task T can be divided into 4 tasks, and you need to complete all the tasks. And you need to complete all the tasks. Because of this AND, so because of this AND, multiplication will come. Okay, and basically what you can do, you can let's assume N1 ways are there, N2 ways are there to complete this task T2, N3 ways are there to complete this task T3, and N4 ways are there to complete this task T4. So this will be your final answer. So this is our product rule. Okay, so this is product rule. You can read. Okay, actually yesterday I forgot to share the slides, so today I will share all the slides. Okay, group theory, graph theory, all the slides I will share. Okay, so you can share, you can try this question. Okay, let me read it. In New Hampshire, license plate consisted of 2 letters followed by 3 digits. How many possible license plates are there? So basically he's saying that you need to make a license plate. In that license plate, what he's saying, he's saying that 2 letters followed by 3 digits means here you can put any letter means A to Z. Here you can put any letter A to Z. Here you can put any letter A to Z. Here you need to put any digit 0 to 9. Here you can put digit 0 to 9. Here you can put digit 0 to 9. So this is how you will make license plate. How many license plates are possible? Try this question. So you can try this question. Let me give you the answer. So the answer will be very easy. See, your task is to make the license plate. This is your task. This is your complete task. And you can divide this task into 5 tasks. You complete this, then you complete this, then you complete this, then you complete this, then you complete this. How many ways are there to complete this task? You can put A to Z. A to Z total 26 are there. Total 26 letters are there. A to Z. Neelam, there are total 26 letters A to Z. In English alphabet, we have 26 letters. Then you have 26 letters to put here also. You have 10 digits to put here. You have 10 digits to put here and 10 digits to put here. So what will be your answer? Your answer will be 26 multiplied by 26 multiplied by 10 multiplied by 10 multiplied by 10. This will be your answer. Okay. So you don't have to calculate this multiplication. Okay, we are not interested in the multiplication, we are not interested in the final value. This procedure we are interested, so this will be our answer. Okay, so here we have applied the product rule because we need to complete this and this and this and this and this. Also remember, let's assume you put A here. Let's assume you put A here. Okay, if you put A here, then you can put again, you can put any letter here. For example, you can put for example A again you can put. Okay, so this is how product rule is applied. Okay, so you can see this is the answer. Okay, I will share the slide and you can refer to this answer also, detailed answer this is. Let's see next example. Okay, so actually this aspect ratio is a little bit, so let me like it might not be clearly visible. Let me read it. A new company with just 2 employees. There are 2 employees. One employee is S, another employee is P. Okay, so there are only 2 employees. So this company is renting a floor of a building with 12 offices. So there are 12 offices. Okay, there are 12 offices. 1, 2 and so on. Total 12 offices are there. Okay, how many ways are there to assign different offices to these 2 employees? How many ways are there to assign different offices to these employees? So this is the question. Basically, you have 12 office. Okay, and you have 2 employees S, P. Okay, and these are 12 offices. So how many ways are there to assign these offices to these employees? For example, you want to assign one office to S, you want to assign one office to P, but you have 12 offices. Then how can you like how many ways are there to assign different offices to these 2 employees? So this you need to find. Try this. So let's see. See, you have 2 employees, okay, S and P. These 2 employees you have, and you want to assign these 12 offices. So what you can do? Very easy. So you can assign any of the 12 offices to him. So basically you can divide this task into 2 tasks. Assign one office to S, then assign one office to P. This is how you can do. Okay, assign one office to S, then assign one office to P. So how many ways are there to assign one office to S? There are 12 ways, because you can assign any office to S. So there are 12 ways. Okay, but remember, once you have assigned one office, let's assume the office 7 you have assigned. Let's assume you have assigned office 7. Okay, now once you have assigned office 7 to S, now you cannot assign office 7 to P, right? Because this office 7 has been assigned to S. So you cannot assign this office 07 to P. So how many ways are there to assign one office to P? There are 11 ways. So there are 11 ways. For example, maybe you can assign office 1. So total how many ways are there? See, you need to assign one office to him and you need to assign one office to him. So basically there is and here. So answer will be 12 into 11. Now Some students are doing this mistake. They are making 2 power 12. Let me tell you why you are making this mistake. You are making 12 offices. So office 1, office 2, office 3 and so on, office 12. And what you are doing, you are saying like this: there are 2 ways to put here, there are 2 ways to put here, there are 2 ways to put here. But no, this is not correct. See, this is not correct. Why this is not correct? First of all, in office 1, of course, you can put either S or P. That is okay. Let's assume you put S. Let's assume you put S. Okay. Once you put S here, okay, now you cannot put S again here, right? Now you can, because you have already put S here. Now you cannot put S in this office. Okay. So you will have to put P here. So you can see, first of all, yes, this is correct. You can put S here. Okay, you can put S. You can put either S or P. You can put any of them here. You can put S or you can put P. Let's assume you put S here. Let's assume you put S here. Now you cannot put S here. So there are not, these 2 ways won't be there. Because now you cannot put S here. You will have to put P here. Now these are not, because you have put S here, P here. Now there is no way, there is 0, 0, 0, 0 and so on. So you can see that's why the mistake. That is the mistake here. Okay. Remember, that is the mistake here. So you need to basically understand, okay, like how things will happen. Like this box, okay, for whom to make this box. So this box will be mapped to S and P. Okay. Okay. So basically you can give any of the 12 office to him. Okay, so there are 12 ways. Let's assume you give office 7. Now there are 11 ways, because you cannot give office 7 to P. So you can give, let's assume, office 5. So how many ways will be there? 12 into 11. Is it clear? You can go through. This is the explanation. This is the detailed solution you can go through. Okay. Next question. How many bit strings of length 7 are there? How many bit strings of length 7? So we need to make a bit string of length 7. For example, 0, 0, 0, 1, 1, 0, 0. This is a bit string of length 7. Bit string means basically, bit means 0 or 1. Bit means 0 or 1. Bit string means this is a length 7 bit string. 1, 2, 3, 4, 5, 6, 7. So the length is 7. So this is a bit string of length 7. You need to tell how many bit strings are there. For example, this is also 7 length bit string. So how many bit string are there? This is the question. Try this. Let's see. See, he is saying that how many bit strings are there of length 7? 1, 2, 3, 4, 5, 6, 7. How many bit strings are there of length 7? So you see, you can put any of the two digits here. You can put either 0 or 1. So there are 2 ways, because you can put 0 or 1 here. Okay, you can put 0 or you can put 1. Now let's assume you have put 0 here. Let's assume you have put 0 here. Now how many ways are there to put 1 digit here? Again you can put 2, because you can again use 0 or you can again use 1. See, again there are 2 ways, because you can again put 0. So there are again 2 ways. How many ways are here? Again 2 ways, because again you can put 0 or 1. Okay, again there are 2 ways, because again you can put 0 or 1. Similarly 2 ways, because you can repeat, like in the bit string you can do like this. So the answer will be 2 power 7, because you need to make a 7 length bit string. You need to make a 7 length bit string. Okay, you can put 0 or 1 here, then you can put 0 or 1 here, because let's assume you put 0 here, then you can again repeat it, right? You can again repeat it. So again you can repeat it again. So basically, for each of the position you have 2 ways. For each of the position you have 2 ways. So finally how many ways are there? 2 power 7, that is 128. Okay, is it clear? Anyone has any doubt in this? So you can see this is the detailed explanation. You can read once I share the slides. You can read. Next we will see the sum rule. What is the sum rule? What is the sum rule? Sum rule is basically is like this. Let's assume you have a task T. You need to do this task T. Okay. Then let's assume either you can task T1, either you can do task T1, or you can do task T2. Okay. Let's assume either you can do task T1 or you can do task T2. Automatically this task T will be complete. Okay. So let's assume there are n1 ways to complete this task T1 and 2 ways to complete this task T2, and let's assume that both are completely disjoint. This task these n1 ways are completely disjoint from n2 ways. Basically any way that we have here, that is not here. So these ways are basically completely disjoint. Okay, so now you have n1 ways to complete this task T1, you have n2 ways to complete this task T2. So how many ways are there to complete this task T? This will be n1 plus n2. Because of this OR, plus will come. Because of this OR, what will come? Plus will come. So this is the sum rule. Okay, don't worry, let's take example and let's try to understand. Let's assume you want to visit. Let's assume you are here. Okay, you are at your home and you want to visit because it's been this pandemic has been going on, and you are at your home, and now you want to visit some city. Okay, now you are thinking, okay, maybe I can go to Rajasthan, or I can go to let's assume Himachal Pradesh. Okay, maybe I can go to Rajasthan, and maybe I can go. So basically you need to visit one place. You want to visit one place. Okay, either you can go to Himachal Pradesh or you can go to Rajasthan. So you can see you want to visit one city. So this is your task. Your task is to visit one city. Okay, one city. But either you can do this or you can do this. Of course, you can either do this or you can do this. Now let's assume 5 cities are here. You have marked 5 cities here. Okay, any of these 5 cities you can visit. Similarly, let's assume here you have marked 6 cities. So you can visit any of these 6 cities. Basically, your task is to visit one city. This is your task, visit one city. So what you did, you divided this task into this task or this task, because you can either complete this task or you can complete this task. How many ways are there to complete this task? There are 5 ways, because there are 5 cities here. So you can complete this task in 5 ways. How many ways are there to complete this task? There are 6 ways. You can see all these ways. Remember one more thing, all these ways are different. For example, this city is different from this city, because this is a city of Rajasthan, this is city of Himachal Pradesh. So that's why you can see that these 5 ways means these 5 cities are disjoint, are different from these 6 cities. So now you can apply the sum rule, because there is OR here. So what will be the sum rule? Sum rule will say 5 plus 6. This will be the answer. So the answer will be 6 plus 5, means you have 11 ways to visit one city. You want to visit one city, you have 11 ways. Okay, so this is the case. Let's take one more example. Let's assume this question. Consider this question. What he is saying in this question, he is saying that there are 2 type of. So he is saying like this: either a faculty or a student. So this is a faculty and this is student. He is saying that so he is saying that a total 37 faculty are there, 83 students are there. Okay, he is saying like this. So total 37 these faculty are there, 83 students are there. And what you want to do, what your university want to do, let me tell you this example. In this example, it is happening like this. Let's assume you have a university. Let's assume some IIT is there. Now in this IIT, what they want to do, they want to send one person to some conference. Let's assume there is some conference, okay, and they want to send one person, they want to send one person to this conference. And now they are thinking, okay, whom to send. Then they are thinking that either we can send a faculty, okay, either we can send a faculty, and how many faculty are there? Total 37 faculty are there. Or we can send a student. How many students are there? Total 83 students are there. 83 students are there. So basically this university is thinking to send one person to the conference. So this university, the task, what is the task? The task is to send one person to the conference. One person, they want to send one person to the conference, okay. Then they are thinking either we can send a faculty or we can send a student. So how many ways are there to send one person to conference? How many ways will be there? So see, to complete this task, either you can complete this task or you can complete this task. How many ways are there to complete this task? There will be 37 ways, because there are 37 faculty and you want to select one faculty, okay, because you want to send one person to the conference. So how many ways are there? 37 ways are there. How many ways are here? 83 ways are here. So you can see, either you can complete this task, means you can select one faculty and you can send this faculty to the conference, or you can complete this task, means you can select one student and you can send this student to this conference. So either you can do this or you can do this. And remember, of course, a faculty is not a student is not a faculty. So these are disjoint, like these 37 ways are completely disjoint from these 83 ways, because these 83 ways means students, these 37 ways means faculties. So finally, how many ways are there to complete this task? This will be 37 plus 83. So the answer will be 37 plus 83, because of this or, because either you can complete this task or you can complete this task, okay. So you can go through this explanation, okay. Now let's see this question. Try to solve this question. Try this. Okay, let's see. What is this question saying? This question saying that there is a student, let's assume this student is there and he want to select one course, okay. So he want to select one project, basically he want to select one project. But there are three list are there, okay. In this list you have 23 projects, in this list you have 15 projects, in this list you have 19 projects. Like maybe he wants to select one project, maybe these are the mathematics project, these are the physics project, these are the chemistry project, okay. He wants to select one project, okay. So you can see in this list 23 projects are there, in this list 15 projects are there, in this list 19 projects are there. Now and now he's saying that, basically he's saying that no project is on more than one list. Basically he wants to say that these 23 projects are different from these 15 projects, and these 15 projects are different from these 19 projects, okay. So now how many ways are there to select one project? How many ways are there to select one project? He wants to select one project. So see, he wants to select one project, then either he can select one from here, or he can select one from here, or he can select one from here, okay. So he can select one from here. How many ways are there to select one from here? 23 ways are there, because 23 projects are there. So how many ways are there to select one project from here? 23 ways are there. Or you can select one from here. How many ways are there? 15 ways are there. Or you can select one from here. How many ways are there? 19 ways are there. So finally, what will be the answer? Because of this or, either you can do this, or you can do this, or you can do this. Means either you can select mathematics project, or you can select physics project, or you can select a chemistry project. So your answer will be 23 plus 15 plus 19. So this will be the answer. Okay, so you can see this is the explanation. You can go through this explanation. Okay, let's see this question. Read this question, what is saying. So try this. This question is a mixture of sum rule and product rule. Now you need to apply both. We have studied the sum rule, we have studied the product rule. Two things we have studied. You need to apply both of them. Okay, in this question you need to basically apply both of these concepts. Try this question. Okay, let's see what he's saying. He's saying that you want to make a password. Okay, this password can be 6 to 8 characters. Okay, where each character is an uppercase letter or a digit. Either you can put an uppercase letter, capital A, capital B, or you can put a digit 0 to 9. Each password must contain at least one digit. How many possible passwords are there? So this is a nice question. Let's see. So actually, okay, to solve this question we need one more concept actually. Okay, right now consider this question. Okay, let's forget about this condition. Let's forget about this condition. We will cover this condition afterwards. Let's forget about this condition. Let's forget about it. Now solve this question. Okay, so focus here. Okay, let me solve it. So what you want to do, you want to make a password. Focus here. Okay, focus here. You want to make a password. Now you can either make a 6-character password. See, you can either make a 6-character password, or you can make a 7-character password, or you can make a 8-character password. Okay, so 6-character password, 6-character password, or 7-character password, or 8-character password. So you can see there is over here, because see, you want to make a password. Either you can make 6-character, or you can make 7-character, or you can make a 8-character. Let's see how many ways are there to make 6-character password. Let's see how many ways are there to make a 6-character password. Very easy. You want to make a 6-character, 1 2 3 4 5 6-character you want to make. Then how many ways will be there? You can either put uppercase letter, or you can put a digit. So how many ways are there? Basically you can either put uppercase letter, or you can put digit. So how many ways are there? 36, because there are 26 letters and there are 10 digits. Okay, so how many ways are there? 36 ways are here. Again 36 ways are here. Again 36 ways are here. Again 36 ways are here. 36, because you can repeat, right? If you put A here, then you can put A again here. If you put 1 here, then you can put 1 again here, or you can put 2 here, 3 here. This is how you can do. So how many 6-character password are there? 36 power 6. This will be the 6-character password. How many 7-character password will be there? 36 power 7. How many 8-character password will be there? 36 power 8. So now this is OR. So 36 power 6 plus 36 power 7 plus 36 power 8. This will be your answer. 36 power 6 plus 36 power 7 plus 36 power 8. This will be your answer. Okay, why this answer? Because either you can do this, or you can do this, or you can do this. Either you can make a 6-character password, or you can make a 7-character password, or you can make a 8-character password. How many 6 character password will be there? 36 power 6. How many 7 character will be there? 36 power 7. How many 8 character will be there? 36 power 8. So now you can just do the summation and this will be your answer. Now let me ask you a question. You want to make a 6 character password. Let's assume you want to make a 1 2 3 4 5 and 6. You want to make a 6 character password, okay? And you can either use capital A to capital Z, or you can use 0 to 9. So these you can use. Basically you want to make a 6 character password and you can use these, okay? But the condition is that at least one digit must be there. 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 At least one digit must be %, okay? Now how many passwords you can make? Try this question. You want to make a 6 character password. You can use capital A to capital Z, or you can use 0 to 9. But the condition is at least one digit must be %. At least one digit must be %. How many passwords you can make? Okay, let's see. See, to solve this question, what you can do like this. This is the way to do this, to solve this question. Let's see, this is the way. First you find the total password, like total password without this condition. This is the condition. Without this condition you find the total password, and then you subtract those passwords in which there is no digit. There is no digit. See, first you find the total password, okay? You just find the total password. You just forget about this condition. You just find the total password. From those password you can minus this password in which there is no digit. These passwords you do not want. See, these are the total password, and these password you do not want, because in these passwords there is no digit. These passwords you do not want, so you can subtract them. How many total will be there? Total will be 36 power 6, because total 36 ways, 36 36 36 36 and 36. So there are 36 power 6. These will be the total, but you need to minus those in which there is no digit. You don't want these password. You don't want such password which have no digit. If you now let's calculate those password which have no digit. Let's calculate those password which don't have any digit. So how many ways are there to put here? There are only 26, because you cannot put a digit. You cannot put any digit. Similarly, there are 26 here because you cannot put a digit. Similarly, 26 here because you cannot put a digit, and so on. So how many will be there? 26 power 6. So this will be your answer. 36 power 6 minus 26 power 6. This will be your answer. Is this correct? So most of the students actually have given incorrect answer. This will be the correct answer. Is this clear, this concept? 36 power 6 minus 26 power 6, because first you calculate the total password, and then from those password you minus those password which you do not want. See, you do not want these passwords, so you minus them, okay? So this will be your answer, okay? This explanation you can go through. Now the next is subtraction rule. What is subtraction rule? Let's assume you can do some task in n1 ways, okay? And let's assume there is another task that you can do in n2 ways, okay? So this task T1 you can do in n1 ways, this task T2 you can do in n2 ways. But let's assume some ways are common, some ways are common, okay? Some ways are common. Basically these ways are common, okay? These are the common ways. Let's assume these are n3 ways. So these n3 ways are common. Basically these n3 ways are common, okay? Then you want to do either T1 or T2. Then how many ways will be there? See, This, because of this or, the plus will come, the summation rule will come. So you will do n1 plus n2, n1 plus n2. But remember, these n3 ways are common. These n3 ways are common. So these n3 ways you have counted here and you have counted here. So these n3 ways you have counted twice. These n3 ways you have counted here also, you have counted here also. So you have counted them twice. But we do not want to count them twice. So what we do, we subtract one time. So we subtract n3, because we have counted these n3 ways, we have counted twice, here also, here also. So we are subtracting them one time so that we do not count them twice. So this is the subtraction rule. Let's see one example. Let's assume that so we can take one example. So let's assume you want to make a password. Okay, you want to make you want to make a string. Let's assume you want to make strings of length 4. You want to make strings of length 4. Okay, but the condition is either they should start with 0 or they end with 1. This is the condition. So understand this question, what I am saying. You want to make strings of length 4, and the condition is either they start with 0 or they end with 1. So how many strings will be there? See this, focus here. So basically here again or is there, means either you can do this or you can do this. Or is there. Okay, either you can do this or you can do this. Now how many ways are there to do this? This is saying that start with 0. So in the first place you have to put 0, because this is saying that start with 0. So there is no choice here. You have to put 0 here. There is no choice here. You have to put 0 here. Here we have choice. We can either put 0 or we can put 1. Here we have choice. We can put 0 or 1. Here we have choice. We can put 0 or 1. So how many will be there? There will be 2 into 2 into 2. So that will be 8. So this task can be done in 8 ways. How many ways are there to do this task? This task is saying that end with 1. End with 1 means the ending symbol must be 1. There is no choice here. This must be 1. Okay. So here we have choice. We can put 0 or 1. Here we have choice. We can put 0 or 1. Here we have choice. We can put 0 or 1. So how many will be there? There will be again 8 ways. So see, this task can be done in 8 ways. This task can be done in 8 ways. But there is one thing you need to notice. There is one thing. These 8 ways have some common things with these 8 ways. So the answer won't be 8 plus 8. Why this won't be the answer? Because some ways here are repeated here also. What are those ways? See, consider these ways in which the first symbol is 0 and the last symbol is 1. These ways, these type of strings you have counted here also, you have counted here also, because these type of strings are starting with 0, so you have counted them here. They are ending with 1, so you have counted them here. Basically these strings you have counted twice. Okay, these strings you have counted twice, so you need to subtract them one time. Okay, so how many ways are there to how many strings are there which you have counted twice? These are the strings that you have counted twice. So how many strings are there? For example, here you have it will start with 0, it will end with 1, so there you don't have choice. But here you have two choices. So finally 4 strings are which you have counted twice. So your answer will be 8 plus 8 minus 4, because these 4 strings you have counted twice. Is it clear? Anyone has any doubt in this? So remember, this is the summation rule. So remember, this is the subtraction rule. Subtraction rule says that you can do this task or you can do this task T2. So you can do this task T1 or you can do this task T2. Okay, let's assume this task T1 can be done in N1 ways and this task T2 can be done in N2 ways. Let's assume some ways are common, means these things you have counted here also, these things you have counted here also, means these things you have counted two times. So you can't just this won't be the answer. N1 plus N1 plus N2 won't be the answer. Why? Because these ways, these things you have counted here and you have counted here. So these things you have counted two times. So you need to subtract them one time. So you need to subtract them one time. So this is the subtraction rule. Try this question. Try this question. Let's see. Okay, let's see this. What he's saying? How many bit strings of length 8 are there? He is asking how many bit strings of length 8. Either start with 1 or end with 0 0. So basically, either you can start with 1. Okay, you can start with 1, or you can end with 0 0. You can end with 0 0. Okay. So first of all, let's count how many strings are there which start with 1. How many are there? There will be 2 power 7, because see, the first position will be 1. There we do not have any choice. The first position have to be 1. We have to start with 1. So there is no choice here. Okay. But in the remaining places we have choice. There are 2 choices here, 2 choices here, 2 choices here, 2 choices here, and so on. So 2 power 7 ways will be there. So this type of strings will be 2 power 7 which are starting with 1. These will be 2 power 7. How many strings are which are ending with 0 0? How many strings are there? See, the last 2 symbols will be 0 0. There is no choice. These have to be 0 0. The remaining symbols can be 0 1 0 1 0 1. Okay. So the answer will be, again here the answer will be 2 power 6. Okay. But there is one point here that you need to notice. These strings are not completely disjoint from these strings. Some strings here are common with some strings here. Okay, so some strings here are common with some strings here. What are those strings? Those strings are starting with 1 and ending with 0 0. These type of strings are common. So these strings you have counted here also, you have counted here also. These strings you have counted 2 times. You have counted here and you have counted here. Okay. So what we need to do? We need to subtract these strings because you have counted them 2 times. So we need to subtract them once. How many strings are there? So the first symbol is 1, there is no choice. The last 2 symbol are 0 0, there is no choice. But in the remaining places you have choice, so there will be 2 power 5. So what will be the answer? Answer will be 2 power 7 plus 2 power 6 minus 2 power 5, because these strings you have counted 2 times. So you need to subtract them 1 time. Okay, so this will be your answer. Many students have gotten the correct answer. Let's see this question. Try this. if there is and in place of or. Which question? Padam, which question you are asking? The last question. Okay, let's see the last question. So Padam is asking this: how many strings of length 8 are there which start with 1 and end with 0 0? So this is very easy. See, your string has to start with 1, so there is no choice. You have to start with 1, so there is no choice here. You have to end with 0 0, again there is no choice here, because your string must start with 1 and your string must end with 0 0. So no choice here, no choice here. But in the remaining places you have choice. Here you have two choices, here you have two choices, two choices, two choices, two choices. So finally how many strings will be there? 2 power 5 strings will be there. Okay, so when there is and, in place of or, if there is and, then there will be 2 power 5. This will be the answer, because basically we are saying that how many strings are there which start with 1 and end with 0 0. So how many strings will be there? 2 power 5 strings will be there. Okay, let's see. Let's see this. A computer company receives 350 applications from computer graduates for something. Suppose that 220 of these applications measured in business, and so how many of these applications measured in neither computer science nor business? So this is a nice question. This type of questions, like many questions, this type of you will see in the in your net exam. So this question is saying like this: computer science, business, computer science. So there are basically, these are the computer science, these are the computer science, and these are the business. Okay, so these are the business. Now he is saying that total 350 applications are there. So total 350 applications are there, like this. So you can make the Venn diagram. In the set theory we have already seen Venn diagram, if you remember. When we studied set theory, at that time we have seen Venn diagram. So how many total are there? Total 350 applications are there. Okay, now he is saying that 220 of these applications are measured in computer science. So how many? 220 are computer science applications. Okay, he is saying that 147 are business applications. 147 are business application, and he is saying that 51 are both computer science and major. Basically 51 are common, means 51 are common. So these are the 51, these are common. Okay, now he is saying that how many of these applications measured neither in computer science nor in business. So he is asking this from total you need to minus these things. Basically he is asking those applications which are neither measured in computer science nor measured in business. So you need to subtract this. So let's find out how many are there. This red area you need to minus. So how many are there in this red area? How many applications are there? So in this red area you have 220 plus 147. But remember, these 51 are common. So these 51 you have counted 2 times. So you need to subtract them 1. See, these 51 are you have counted these 51 2 times, here also. So you need to subtract them 1 time. So this will be your answer. Your answer will be 350 minus, because this 350 is the total number of applications. From these 350 you need to subtract these applications, because he is asking how many applications are there which are neither measured in computer science nor measured in business. So that's why you need to minus it. So what is this value? You can calculate. This is nothing but 7 6 and this is 3 minus 51. So this will be over 613. So 350 minus 316, this will be the answer. Okay, You can see this is the detailed solution. You can refer to this solution when I share these slides. At that time you can refer this solution. Let's see the division rule. What is this division rule? This is very easy actually. See, let's assume that there is a party. Let's assume there is a party. There is a party. In this party, let's assume that there are some parents. Okay, some parents are coming, and each parent has. Okay, let's assume some mothers are coming. Basically, some mothers are coming. Okay, some mothers are coming, and each mother is coming with her two children. So each mother has two children. Okay, each mother has two children. So basically in this party, who are coming in this party, mothers are coming, and their children are coming, and each mother has two children. So children are coming. Now if I ask you, let's assume that there are 50 children. Then can you tell me how many mothers are there? In this party, my question is, let's assume 50 children are there. Then how many mothers are there? This is the question. How many mothers? So yes, very easily you can do. The mothers will be, the total 25 mothers will be there. Why? See, each mother has two children. Each mother has two children. Okay, so like mother 1, she has two children, mother 2, she has two children, and so on. So total how many children are there? He is saying total 50 children are there. Total 50 children are there. So how many mothers will be there? There will be 25, because 50 divided by 2. So there will be 25 mothers. So this division rule, what it is saying? It is saying like this. Let's assume you have a set. Let's assume this is your set. Okay, and let's assume this is another set. So this is your set A, this is your set B. Now let's assume that these elements are assigned to this element. These elements are assigned to this element. Let's assume these elements are assigned to P. These elements are assigned to Q. These elements are assigned to R. Let's assume this is like this. Okay, these elements are assigned to P, these elements are assigned to Q, these elements are assigned to R, and so on. So let's assume that these are D elements, these are D elements. So these D elements are assigned to P, these D elements are assigned to Q, these D elements are assigned to R, and so on. It is happening. Let's assume total number of elements here are N. Then can you find how many elements will be there here? This is the division rule. Can you tell me how many elements will be there in this set B? This is the question. Tell me. So yes, you have guessed it right. So the answer will be N by D. Because you see, these D elements are assigned to P. Means for these D elements, you have one element. For these D elements, you have one element. For these basically for every D elements, you have one element. It is like this. It is like this. For these D people, you have one element. For these D people, you have one element. For these D people, you have one element. So how many elements will be there? There will be N divided by D. Is it clear? Like in the mother's example, see the mother's example. In the mother's example, what was happening? This was the set of children. This was the set of children. Okay, and this is the set of mothers. Now, basically you can see these two child have this mother. Let's assume mother 1. These two child, so these two child have mother 1. These two child have mother 2. These two child have mother 3, and so on. This is how it was happening. Now the total number of children here are 50. Then how many mothers will be there? The mothers will be this 50 divided by this 2. Basically this is your N and this is your D. So basically N divided by D. Is it clear? So this division rule, this is a very basic rule, you can see. So this is how you can find, this is how you can apply the division rule. Similarly, if I give you the number of mothers, let's assume I do not give you number of children. I do not give you number of children, I give you number of mothers. Let's assume I give you number of mothers equal to 100. So this 100 is the number of mothers. Then I ask you how many children will be there. Very easily you can answer. There will be 200 children because each mother has 2 child. So there will be 200 children. Okay, because see, this formula you can apply. 100 is equal to n divided by d. You want to find n. This d is 2. So n equal to 100 into 2. So this is how you can do. So this is your division principle. Okay. So let's take example. So try this question. This is a very standard question. So this is a very standard question. Like many times you will see this type of this question, this same question you will see many times. So try this question. Okay, actually let me solve it. So what is this question? Okay, focus here, let me solve it. In this question he is saying that how many different ways are there to seat 4 people around a circular table. So this is a circular table and you want to let's assume 4 chairs are there, A, B, C, D. 4 people are there and you want to make them sit around this circular table. Okay, now he is saying that 2 sittings are considered the same when each person has the same left neighbor and same right neighbor. Okay, so what he is saying like this. Let's assume this is circular table. Okay, so this is A, this is B, this is C, this is D. One day they are sitting like this. Let's assume. See, this is the circular table. Now, if you rotate this table, let's assume you rotate this table on the left side, then what will happen? This A will come here, B will come here, C will come here, D will come here. In the question, he is saying that this sitting arrangement is same as this sitting arrangement. Why? Because see, in this sitting arrangement, what is happening? The left of A is B, the right of A is D. The left of A is B. In this arrangement also you can see the left of A is B and the right of A is D. So you can see what I am saying. Basically in the question he is saying that this arrangement is same as this arrangement. This is what he is saying. Okay. So basically this is a circular table. So if you rotate this circular table, okay, let's assume in this circular table, let's assume this is the arrangement. Okay, so one day they are sitting like this. This is a family. This family has 4 people and they are sitting like this, and this is a circular table. So if you rotate this table, let's assume you rotate this table to the left, to this direction, to the left direction, basically you rotate it clockwise, then what will be the arrangement? Arrangement will be A, D, B, C. This will be the arrangement. He is saying that these 2 arrangements we consider to be same. Similarly, you can rotate this again. Then what you will get? You will get A, D, B, C. He is saying that this arrangement is same as this arrangement. Now again you can rotate here. Then what you will get? You will get B, C, D, A. He is saying that this arrangement is same as this arrangement, is same as this arrangement, is same as this arrangement. Now if you again rotate it, then you will get this arrangement. He is saying that all these 4 arrangements are same. So basically you need to find how many different arrangements are there. So okay, one student might think like this, because A, B, C, D, 4 people are there. So what you can do, you can put one person here. Let's assume 4 chairs are there. Okay, this is one chair, this is another chair, this is another chair, and this is another chair. Now some student will be thinking like this. In this chair I can put any of the 4 elements. Okay, any of the 4 elements. Now once I have put, for example, let's assume I have put this person A here, then I can put 3 elements here, because 3 choices are here, because you have already put one person here. So you cannot put him here, right? Because you have already put him here. So there are 3 ways here, 3 choices here. Here we have 2 choices, here we have 1 choices. So how many total arrangement will be there? Total arrangement will be 24 will be the total arrangement. But remember, I told you 4 arrangements are similar. Like I told you that if you have this arrangement, then this arrangement is same as this arrangement. Okay, and this arrangement is same as this arrangement. Similarly, basically each arrangement has 4 similar ways. So what I am saying like this. So you have total 24 ways. Total 24 you found. But in this 24, what is happening? These 4 ways are actually, you should not count them 4 times. You should count them only once. Similarly, these 4 you should count only once. Similarly, these 4 only you should only count them once, because these 4 are same. I told you these 4 are same. Similarly, these 4 are same. Similarly, these 4 are same. Remember, see, this is A, B, C, D. This arrangement will have similar arrangement. Total, how many similar arrangement will be there? There will be total 4 arrangements similar to this. Okay. Now put this here. Now this also will have 4 arrangements similar to it. So you can see these 4 arrangements should be counted one time. These 4 arrangements should be counted one time. These 4 arrangements should be counted one time, and so on. So now you can apply the division principle. Answer will be 24 divided by 4. Okay, some students are doing this mistake. They are doing 24 minus 4. Let me tell you one thing. See, I took this arrangement. Let's assume this is father, mother, and the boy and the girl. Let's assume this is one arrangement. See, this arrangement is same as this arrangement, because you can just rotate it clockwise. So this arrangement is same as this arrangement, and this arrangement is same as this arrangement, father, mother, boy, girl. And this arrangement is same as this arrangement, father, mother, boy, girl. So remember, you can see these 4 arrangements are similar. But remember now, so if you count, basically you have counted these 4 arrangements 4 times, but you should count them only one time. Okay. Now similarly you can have, for example, maybe boy, father, mother, and boy, father, and let's assume this is the, now this arrangement also has similar arrangement, 4 similar arrangement. Okay, you can rotate it. So you can see one thing that each arrangement is basically having 4 similar arrangement. Each arrangement is having 4 similar arrangement. So you have total 24. So how many unique arrangement will be there? There will be 24 divided by 4. By division principle, you can apply this. So the answer will be 6. Anyone has any doubt in this? Anyone has any doubt in this? So you can go through this explanation, okay? If anyone has any doubt, then you can ask. Okay, actually let me tell you a trick, or you can solve like this. Whenever you have, let's assume you want to put 6 people. Let's assume you want to put 6 people. So you have 6 chairs around a circular table. You want to put 6 people. Okay, then the best way is actually like this. Fix one people. Fix one. For example, you put the father here. You put the father here. Fix one people. Okay. Okay. Nivedita is saying not getting. So Nivedita, focus on this method. I'm telling a different method. Focus here. Okay. So this method. Let's assume you want to put 6 people around a circular table. This circular table has 6 chairs. Okay. And you want to put 6 people here. Then if in the question he is saying, let's assume in the question he is saying that basically when you rotate this circular table to the left, then you will get the same arrangement. Let's assume this is the question. Okay. Then how many different arrangements will be there? So to find these different arrangements, what you can do, very easily you can do, fix one person. For example, maybe you can fix father. So you can put father here. Like this chair you can fix. This chair you can fix. So this is the chair for father. Now you can fix this chair. How many remaining chair are there? How many remaining people are there? 5 people. These 5 people you can put anyhow you want. For example, these 5 people you can put like this: 5 here, 4 here, 3 here, 2 here, 1 here. Basically 5 into 4 into 3 into 2 into 1. So this will be your answer. Is it clear, Nivedita? So let's see. In the last example also we can see. In the last example we have 4 chair. In the last example we have 4 chair. What you can do? Put one, fix one person. So you can just fix one person. Okay, fix one person. For example, father. You can fix father here. Now you have three remaining people. So how you can do? You have three choices here. You have two choices here. You have one choice here. So how many ways will be there? 3 into 2 into 1. So the answer will be 6. So this is another way to solve that question. Okay, this is easy way, right? So just in the circular table, like in this type of question, in this type of circular table question, okay, this is how you can solve. One person you can fix. Okay, just fix one person, and remaining people you can arrange. Okay, so let's see the next principle, that is pigeonhole principle. The pigeonhole principle. This, what is this pigeonhole principle? This is very easy principle actually. This pigeonhole principle says that, let's assume you go to a hotel. You are 4 friends. Okay, so 4 friends are there. Okay, let's assume A, B, C, D. These are the 4 friends, and you are going to a some hotel, and in that hotel, let's assume there are 3 rooms. Room 1, room 2, room 3. So you want, of course, you want to stay in these rooms. Then you can see 4 people are there and 3 rooms are there. Then what should happen? At least one room must have more than 1 people. For example, you can put A here, B here, C here. Now you have to put D in one of these rooms. So what I can say? I can say that at least one room will have more than 1 people. Right? So this is the pigeonhole principle. Very intuitive principle it is. Basically, if you have, let's assume, if you have 6, let's assume you have 6 people, and there are only 5 rooms. Let's assume there are only 5 rooms, means 1 room, 2, 3, 4, 5 rooms are there. Then you can see that at least two people must go to the same room. Okay, so at least 2 people, because let's assume there are 6 people, A, B, C, D, E, F. These are 6 people. So at least 2 people must go to the same room. Why? Let's assume you put A here, B here, C here, D here, E here. Okay, now this F has to go inside one of these rooms. So you can see, let's assume you put F here. Then you can see that at least one room has more than 1 people. So this is your pigeonhole principle. Very intuitive principle this is. Okay, so let's see the statement. Now the statement is like this. Let's assume there are n pigeons. Okay, n pigeons are there, but there are only n minus 1 nest, or you can say less than n nest. Basically, n pigeons are there, but the holes are less than n. The holes are less than n. So let's assume there are m holes, and this m is basically less than n. Now what should happen if this is the situation that you have more pigeons and the number of holes are less than n? Then what should happen? At least two pigeons must go to the same hole. So this is the idea basically. If you have n people, let's assume you have n people, and you have less than n room, then what should happen? At least 2 persons must go to the same room. So this is the idea. This is the basic idea of pigeonhole principle. Let's try to solve this question. Try this. So okay, let me try this. He's saying that in a group you have 367 people. So you have 367 people. So these are the 367 people you have. Now you know that for example, in 1 year, how many days are there? In 1 year, you take like 30. This is the maximum days you can have in 1 year, 366. Okay, these are the maximum days you can have. Sometimes you have 365, sometimes you have 366, but this is the maximum you can have. Okay, but the number of people are 367. So it's like this. The number of days are 366 and number of people are 367. So at least 2 people must have the same birthday, right? At least 2 people must have same birthday. It is guaranteed that at least 2 people must have same birthday, because there are 367 people and the number of days are 366. So at least 2 people must have same birthday. Okay, so this is the pigeonhole principle. Let's see next question. In this next question, he is saying that assume that you have 27 English words. Okay, So you have assume that you have 27 English words, word 1, word 2, and so on. 27 English words you have. Then you know that there are only 26 letters. So you have 27 words, okay, but in English you have only 26 letters. So at least two of these words must begin with same letter, right? At least two words must begin with the same letter, because there are 27 words and the number of letters are only 26. So the pigeonhole principle says that at least two words must start with same letter. So this is the pigeonhole principle. Very intuitive. Let's see this question. Try this. What he's saying in this question, he's saying how many students must be in a class to guarantee, you want to guarantee that at least two students receive the same score on the final exam. And in the final exam, how many scores you can get? For example, you can get 0, or you can get 1, or you can get 2, or you can get 3, and so on, or you can get 100. So these are the marks that you can get. Tell me, how many students must be there in the class? Minimum how many students must be there in the class to guarantee that at least two students will have the same score. So you can see, first of all, these are your holes. So how many holes are there? Total 101 holes are there. Okay, see how many holes are there? Total 101 holes are there. And how many people you have? How many people you need? At least how many people you need so that at least two students have the same marks? So you need 102. These many person you need at least to guarantee that. To guarantee that at least two students will get the same marks. So the answer will be 102. What is the reason? See, okay, very easy. Let's assume you have 101 students. If you have 101 students, then you cannot guarantee that at least two students will have same score. Why? Because maybe one student can get 0, another student can get 1, another student can get 2, another student can get 3, and so on. Another student can get this 100. So you can see that if you have 101 students, then you cannot guarantee that at least two will have same marks. You cannot guarantee. But if you have 102 students, then you can guarantee that at least two students will have same marks. Why? See, number of holes are 101. These are the holes. So if you have more students than the number of holes, then you can guarantee that at least two students will go to the same hole. Means at least two students will have the same score. So that's why the answer is 102, because we have 101 holes. So to guarantee that at least two students get the same marks, you need 102 students. Because if you have 101 students, then you cannot guarantee. Okay, you cannot guarantee. Maybe every student is getting different marks. Okay, so that's why the answer will be 102. Basically, answer will be actually like this: anything more than or equal to 102. So in the options, if they are asking minimum, then you will answer 102. If they are not asking minimum, then in the options you just try to find which number is greater than or equal to 102. Okay, for example, in the options he can give you like this option, he can give you like this, he can give you these options. The first option 1 will be 50, option B will be 99, option C will be 100, and option A will be 101, and option D will be 500. So what will be the answer? Answer will be 500. Okay, If these are the options, then the answer will be 500. Why? Because you need at least 102 students. At least 102 students you need to guarantee that at least two students will go to the same mark. At least two student will get the same score. Okay, so this is how you can. If they ask you minimum number of students, then the answer will be 102. If they ask you minimum number of students, then the answer will be 102. Okay, this is the solution. You can just check it out. Now we will see permutation combination. So actually this permutation combination is nothing but your product rule. So we have already seen the product rule. Okay, so I told you one thing. This product rule, sum rule, subtraction rule, division rule, these are the basic rules. Okay, and all the things that we will study now, we are going to use these basic rules again and again. Okay, so what is this permutation? First of all, let's understand this permutation. What is this permutation? Permutation is like arrangement. This permutation is like arrangement. Permutation is like arrangement. For example, let's assume you are arranging like this: A, B, C. This is a permutation. B, A, C. This is a different permutation, because remember this is an arrangement A, B, C. The A is in the first place, B is in the second place, C is in the third place. So this is one permutation. This is another arrangement, or you can remember this is another permutation, has this another name, arrangement. So this is one permutation. This is different permutation. Why? Because now in this permutation B is in the first place, A is in the second place. So basically in permutation, order matters. Order matters. Order matters. For example, this BCA, this is a different permutation. For example, CAB, this is a different permutation. For example, CBA, this is a different permutation. For example, ACB, this is a different permutation. So these 6 permutations you can have. You can have 6 arrangements. You can have 6 permutations if you have 3 elements. If you have 3 elements, then how many permutations you can have? 6 permutations you can have. Basically, permutation is nothing but an arrangement, and in permutation the order matters. Like ABC is different from BAC, this BAC is different from BCA, this BCA is different from CAB, CAB is different from CBA, and so on. Okay, so this is the idea of a permutation. Now let's see one example for permutation. Let's assume there is this exam, NET exam is there, and let's assume in this NET exam you have rank 1, rank 2, rank 3, and so on. Okay, and basically on each rank you can have exactly 1 student you can have. Okay, so let's assume there are total 10 ranks are there. Okay, so 1 2 3 4 5 6 7 8. So let's assume you have total 10 rank, means the rank 1, rank 2, rank 3, rank 4, rank 5, rank 6, rank 7, rank 8, rank 9, rank 10. Let's assume these are the 10 ranks you have. Okay, and you have total 20 students. Then how many different results are possible in the top 10? In the top 10, how many different results are possible? This is the question. Are you getting this question? You have top 10 ranks, and we are only looking at top 10 ranks. Okay, we are not looking at 11th 12th rank. Okay, we are only interested in the top 10 rank. You have 20 students. How many results are possible? How many different results are possible? So to solve this question, you can apply your product rule. Your product rule. The product rule says that how many ways are there for this first rank? For this first rank, 20 ways are there, because 20 students are there. So any of them can get first rank. Okay, so there are 20 ways for this first rank. Now, once you have put a student here, let's assume you put a student A here. This A student you have put here. Now, how many ways are there for the second rank? This second rank has 19 ways. How many ways are there for the second rank? This has 19 ways. Why? Because the first rank, you have already put A in the first rank. So for the second rank, you have 19 ways. For the third rank, how many ways are there? 18 ways, because any of the remaining 18 students can come here. So 18 ways are there, and so on. Now 17 ways, 16 ways, 15 ways, and so on. You can just keep it calculated. 14 ways, 13 ways, 12 ways, 11 ways. So finally, how many different results are possible? you need to do this and this and this and this, because you need to make the result, means you need to make the top 10 rank. So how many results will be there? How many different results will be there? This will be 20 into 19 into 18 into and so on into 11. This will be the answer. Are you getting? See, this is the product rule that we have applied. We have done nothing. We have just applied the product rule. Now let's change the question. In the question, what we have, let's assume you have top 10 ranks. Again, you have top 10 ranks. Okay, 10 ranks you have. And you have 10 students. Now how many results will be there? Now how many different results will be there? Tell me. So you can try. The answer will be, you can see very easily you can answer. So see, you have 10 ranks and you have 10 students. So for the first rank you have 10 ways. Because any of these 10 students can get the first rank, right? So 10 ways you have for the first rank. For the second rank, how many ways are there? 9 ways. Why? Because once a student has gotten first rank, then you cannot put him in the second rank, right? Okay, so 9 ways are there. Similarly here 8 ways and so on. So when you multiply then 10 into 9 into 8 and so on into 1, this you will get. This is called 10 factorial. This we will write like this, 10 factorial. Basically this number 10 into 9 into 8 into and so on till 1, this we will write 10 factorial. So what is 10 factorial? Let me write it. 10 factorial is nothing but start with 10 and then write 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is your 10 factorial. For example, what is 6 factorial? That is nothing but 6 into 5 into 4 into 3 into 2 into 1. This is your 6 factorial. For example, what is n factorial? N factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 and so on 3 2 1. So this is how you can find n factorial. Okay, so this is your n factorial. For example, what is 1 factorial? 1 factorial is 1. 2 factorial, what is this? 2 into 1. 3 factorial is what? 3 into 2 into 1. So 3 factorial is 6. 2 factorial is 2. 1 factorial is 1. What is 4 factorial? 4 into 3 into 2 into 1. So this will be 24. What is 5 factorial? This will be 5 into 4 into 3 into 2 into 1. So this will be 120. What is 6 factorial? 6 factorial is nothing but 6 multiplied by 5 factorial. This is how you can write. Basically, n factorial is nothing but n multiplied by n minus 1 factorial. Okay, so 6 into 5 factorial. What is 5 factorial? This is 120. So 6 factorial will be 720. So this is how factorial is defined. Okay, so now let's see. If you have, let's assume you have what is this permutation? Let's see. Let's assume you have n elements. So n students are there. Let's assume n students are there, and you only want to find the R ranking, means you only want to find the R ranks. So total n students are there, but you want to find the R ranks. So how many results will be there? The results will be NPR. We will see what is this NPR. Don't worry, we will see. But this is the basic. Let's see what is this NPR. What is this NPR? This NPR is a symbol. And this symbol is like this: n factorial divided by n minus r factorial. This is your NPR. Okay, n factorial divided by n minus r factorial. So for example, if I ask you what is 3p3, let's assume if I ask you what is 3p3, then it will be 3 factorial divided by 3 minus 3 factorial, that is 0 factorial. Remember, 0 factorial is 1. we take this 0 factorial to be 1. Okay, just we define it like this. 0 factorial is equal to 1. This is how we define. Okay, now 3 factorial divided by 0 factorial. What is 3 factorial? This is 6 divided by 1, so this will be 6. So you can see 3p3 is 6. Let's see the next symbol. Okay, so this npr, you got it right. Npr is nothing but n factorial divided by n minus r factorial. This is your npr. We have another symbol, ncr. What is this ncr? Ncr is nothing but n factorial divided by n minus r factorial into r factorial. This is ncr. What is ncr? ncr is n factorial divided by n minus r factorial into r factorial. This is ncr. You can notice one thing. This thing is nothing but npr. Basically npr divided by r factorial. This is how you can write ncr. So you can say that ncr is npr divided by r factorial, or you can say that npr is nothing but ncr multiplied by r factorial. Okay, so let's take one example. What will be 4c3? What will be 4c3? Very easily you can answer. 4c3 means 4 factorial divided by 4 minus 3 means 1 factorial multiplied by r factorial means 3 factorial. What is this 4 factorial is nothing but 4 into 3 factorial divided by 3 factorial. 3 factorial will cancel, so the answer will be 4. Now tell me, what is 4c4? What is 4c4? 4c4 is 4 factorial divided by 4 minus 4 means 0 factorial into 4 factorial, and basically n factorial, n minus r factorial into r factorial. So this will be 4 factorial and 4 factorial will cancel, so the answer will be 1, because 0 factorial is 1, so the answer will be 1. So this is how you can find ncr, npr. And let me give you one more property. See, before we see the property, just this is how this npr will be used. Let's assume you have n elements, all are different. Let's assume you have n distinct elements, means all are different. N distinct elements you have. Let's assume you want to arrange r elements out of them. So basically, for example, you have 10 toys. Let's assume you have 10 toys, and let's assume you want to take 3 out of these, and these 3 toys you want to arrange like this. You want to arrange them like this. So out of n elements, you want to arrange r elements. Okay, out of n elements, you want to arrange r elements. Then how many arrangements will be there? The answer is npr. This will be the answer, npr. For example, we have seen this question. If you remember, we saw this question that if there are 10 ranks, let's assume in the NET exam there are 10 ranks, okay, and 20 students are there. So how many results will be possible? So how many results will be possible? See, you have 20 elements, but you only want to arrange 10 out of these 20. So you have 20 elements, you have 20 students, but you want to arrange 10 out of these 20. So what will be, how many results will be possible? Results will be 20pr, 20p10, because you want to arrange 10. So this out of 20 you want to arrange 10. So this will be your answer, 20p10. Remember, out of 20 you want to arrange. This p means permutation, this p means arrangement. So out of 20 you want to arrange 10 elements. So this will be the answer, 20p10. Okay, so this is how you can find actually this 20p10. Actually, when you solve this 20p10, then what you will get? You will get this 20 into 19 into 18 and so on. You will get this. And this was the answer we got. If you remember, this answer we got using the product rule. Okay, so this is how you can get it. Actually, this answer we got using product rule. We did not apply permutation, this formula we did not apply, but you can apply this formula directly. Okay, so you can see this product rule, sum rule, division rule, subtraction rule. These are very important because these are the basic rules. Okay, all other concepts we can derive from these concepts. So the answer will be 20p10. Okay, so basically, if you have n elements, let's assume n distinct elements you have. Distinct means n different elements you have. So n distinct elements you have. Out of these n elements, you want to arrange arrange, remember in arrangement the order matters. Like in the ranking, when you want to give a rank, then order matters. For example, this is having first rank, this is having second rank, this is having third rank. Remember, when you do this, then this is a different result. Why? Because now this B has first rank, A has second rank, C has third rank. So in the arrangement, order does matter. So when order matters, okay, or you can say when you want to do the arrangement, or when you want to do the permutation, out of n elements, if you want to arrange r elements, then the answer will be npr. These many arrangements will be there, npr. So like this question you can very easily you can solve. In this question what he is saying, let's assume you have group of total 5 students are there. So total 5 students are there, but you want only 3 students, and you want to take a picture, like you want to put them in a line. You want to put them in a line, and you want to put 3 students in a line, and you want to take a picture. So how many different arrangements are there basically? So the answer will be 5p3, because here he is basically saying that you are putting them in a line. When you are putting 3 things in a line, then order does matter. When you are putting like this, then this is the first element in the line, this is the second element in the line. When you do like this, then this is the first element in the line, this is the second element in the line. So this is like a permutation because order matters. This is like a arrangement. So the answer will be 5p3. Now in this question he is saying that if you want all the 5 students, then answer will be 5p5. This 5p5 is nothing but 5 factorial. Actually this npn, what is this npn? Let's try to find what is this npn. This npn, this is nothing but n factorial divided by n minus n factorial, n minus n factorial. So this is nothing but n factorial divided by 0 factorial, and 0 factorial is nothing but 1. So finally you will get n factorial. So npn is actually nothing but n factorial. Okay, so you can see this solution. Let's move on. So this is the theory basically. You have n elements. Out of these n elements, you want to arrange r elements. Out of these n elements, you want to arrange r elements. Then how many arrangements will be there? npr. These many arrangements will be there. Okay, so this is the permutation, this is the arrangement. Okay, let's see the next thing. So this is the question. You have a set S 1 2 3. Now how many ordered arrangement will be there? So this is again nothing but permutation. So basically if you have 3 elements 1 2 3, these are the 3 elements that you have. Okay, and you want to find how many different arrangements will be there for these 3 elements. So how many will be there? The answer will be 3p3. So the answer will be 3 factorial. This is how you can find. And if he asks you, let's assume you have 3 elements, but you only want to arrange 2 elements. So out of these 3, you want to arrange 2 elements. Then what will be the answer? Answer will be 3p2. What is this 3p2? 3p2 is nothing but 3 factorial divided by 3 minus 2, that is 1 factorial. So 3p2 means 3 factorial divided by 1 factorial. So the answer again will be 6. Okay, so this is how you can solve these questions. Okay, 3p2 you can see 3p2 is nothing but 3 factorial divided by 3 minus 2, that is 1 factorial. 1 factorial is 1 and 3 factorial is 6. So the answer will be 6. So this is how you can find the number of permutation, and this is your NPR. Remember this NPR is sometimes written like this, PNR. This is how we can write this NPR. We can write like this, PNR, or you can write like this. So both are all these 3 are same. Okay, NPR, or you can write PN comma R, or you can put like this. All these things are same. Now let's see this question. You can very easily you can answer this question. He is saying that you basically want to give 3 prizes: first prize, second prize, third prize. These 3 prizes you want to give, and total 100 people are there, total 100 students are there. Then how many different basically prize orders are there? Basically how many different ways you can give these prizes? So See, total 100 students are there. You want to give first prize, second prize, third prize. Basically you want to take 3 students out of these 100 students. You can take 3 students and then you can arrange them. Because this is first prize, second prize, so order matters. Okay, order matters because this is different from this, because here he is getting first prize, here this B is getting first prize, so this order does matter. So what will be the number? Answer will be 100 P3. This will be the answer, 100 P3. Okay, so you can see this is the solution, 100 P3. Let's see next question. In this question what he is saying, you have 8 runners. So total 8 people are there who are running in a race. Okay, and he is saying that the winner, means the first ranker, is going to get the gold, the second ranker is going to get the silver, and the third ranker is going to get the bronze. So he is saying that how many different ways are there to award these medals. So this is he is asking basically, how many different ways are there to award these medals. You have 8 runners, total basically 8 people are there, 8 people who are running in a race. Okay, some marathon is there, whatever. So 8 people are running, and the first person who basically who wins, he will get gold, the second person will get silver, the third person will get bronze. So how many ways you can assign you can give these medals? How many ways are there? How many different ways are there to give these medals? So the answer is again same, answer is 8P3, because total 8 elements are there. Out of these elements you want to arrange 3 elements. So out of n elements you want to arrange r elements. Then how many arrangements will be there? These many arrangements will be there. So the answer will be 8P3. What is 8P3? 8P3 is nothing but 8 factorial divided by 5 factorial. This is nothing but 8 into 7 into 6 into 5 factorial divided by 5 factorial. This 5 factorial you can cancel out. So the answer will be 8 into 7 into 6. Okay. Next, so this is how you can find. So the answer will be 336. Now let's see combination. Now we will see combination. See, so far we were discussing these permutations. In permutations, order matters. In permutations, order matters. For example, this A, B, C, this is different from B, A, C, means both are not same. This is different from A, C, B. As I told you, order matters in the permutation. In the permutation, order matters. Now we will see combination. In combination, order does not matter. For example, let's take one example. Let's assume there are 10 students. Total 10 students are there. You want to select 3 students and you want to put them in your cricket team. So you want to make cricket team. So you want 3 students to put in a cricket team. Okay, you have a cricket team, and in that cricket team you want to put 3 students. You need 3 students. Okay, so out of these 10 students, you need 3 students, and you want to put them in your cricket team. So of course the order does not matter. You only need 3 people. You need 3 people. Okay, so for example, if you select A, B, C, then this is one selection. Remember, this is not a different selection because these two are same selection. Because you want 3 people. Okay, so this selection is giving you A, B, C. This selection is giving you B, A, C. So both are same selection, right? You want 3 people. So that's why you can see this combination is called selection. Remember, this combination, the another name for combination is selection. And in selection, order does not matter. The only thing that matters is you need 3 students out of 10 students. This is the only thing that matters. Basically, you want to select 3 students out of 10 students. Okay, so this is your combination. So what will be the answer? The answer is very simple. You want 3 students. See, you want 3 students out of these 10 students. So how many ways are there? 10 ways are there to take one student. Once you have taken this student, wait a second. No. No, this will actually, this will be arranged. No, so what I'm saying, wait a second. So out of 10 students, you want to select 3 students. You want to select 3 students. Out of these 10 students, you want to select 3 students. So order does not matter. So how many ways are there to select 3 students? The answer will be 10C3. Out of 10, choose 3. This is like this. 10, choose 3. Choose means selection. Choose means selection. So you can say 10C3 means out of 10, select 3 student. Out of 10, choose 3 student. Okay, so this is your combination. So this will be your answer. So if you have, let's assume you have n student, n elements, and distinct and different elements you have. Let's assume n different elements you have. Out of these n elements, you want to select r elements. Out of these n elements, you want to select r elements. Then how many ways are there to select r elements from n elements? This will be NCR, means out of n, choose r elements. This will be your answer. Out of n, choose r elements. This will be your answer. So you can solve this question. Try this question. How many different committees of 3 students can be formed from a group of 4 students? So basically he's saying like this. You have 4 students. Let's assume A, B, C, D. These are the 4 students you have. You want to make a committee. You want to make a committee. In this committee, you need 3 students. So how many committees you can make? How many different committees you can make? Okay. So the same thing, you have 4 students and in the committee you need 3 students. So how many committees you can make? 4C3 means out of these 4 students, select 3 students. Select 3 students. So because order does not matter, right? In the committee, if in the committee A, B, C are there, then the order does not matter because this is a committee, this is a meeting. So the answer will be 4C3. What is 4C3? This is nothing but 4 factorial divided by 4 minus 3 means 1 factorial into 3 factorial. So this will be 4. So the answer will be 4. This is how you can solve. So basically this is your NCR. We have already seen NCR is nothing but n factorial divided by n minus r factorial into r factorial. Okay. So let's see this question. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from? So basically what he is saying, you have cards. Okay, 52 cards you have. And you want to select 5 cards out of these 52 cards. You want to select 5 cards. So how many ways will be there? Out of 52, you want to select 5 cards because the order does not matter. Okay, in the cards game, what happens if I give you 5 cards? Then the order does not matter. The only thing that matters is what are those 5 cards. Okay, so order does not matter, like it won't matter, like this order won't matter. Like if I give you 4 cards, 1 is king, 1 is queen, 1 is ace, 1 is 2, 1 is 3. So this order does not matter, like in which order I gave you in this order, then this order does not matter in the cards game, you know. So these many ways are there to select 5 cards out of 52 cards. These many ways will be there. Now if I ask you how many ways are there to select 47 cards, then what will be the answer? Answer will be 52C47. If I want to ask you how many ways are there to select 47 cards. Now this is an important property is coming, so focus here. NCR is equal to NCN minus R. Okay, we can prove it very easily. What is this NCR? NCR is nothing but n factorial divided by n minus r factorial into r factorial. What is this? This is nothing but n factorial divided by n minus n plus r factorial into n minus r factorial. What is this? This is your n factorial. This is your r factorial, and because this n cancel out, so you can see both are same. So remember this thing, that NCR is equal to NCN minus R. So you can say like this, 52C5, this is equal to 52, this is equal to 52C47 because NCR is equal to NC n minus R. Okay, this is how you can prove NCR is nothing but this, NC n minus R is nothing but this. You can see both are equal. So both are equal. This is the property. Now let's see this question. How many bit strings of length n contain exactly R ones? How many bit strings of length n contain exactly R ones? Try this. Okay, let me so you can solve it. He's saying how many bit strings of length n. So length n you have contain exactly R1s. Exactly R1s. Okay, so you have bit string of length n. You want to make a bit string of length n, and in this bit string exactly R1s should be there. Exactly R1 should be there. So what will be the answer? All you have to do just select R positions. See, you have n positions. So from these n positions you select R positions. Okay, and in those R positions what you can do, you can put ones. In the remaining position you can put 0. So this will be the answer will be NCR. This NCR is equal to NC n minus R. Both are same. NCR is equal to NC n minus R. Did you get it? See, I am saying like this. Let's assume you want to make 4 length bit string. You want to make 4 length bit string, and exactly 2 ones must be there. Exactly 2 ones must be there. So what you can do? You want exactly 2 ones. So what you can do? You can see these 4 positions you have. From these 4 positions you can choose 2 positions. Let's assume you choose this position and this position. Let's assume now in these positions you can put 1. In the remaining position automatically 0 will come. In the remaining position automatically 0 will come. So the answer will be 4C2. So this is how basically if you want to make n length bit string such that exactly R ones must be there, then what you can do, from n position you can select R position, and in these R positions you can put ones. In the remaining positions 0 automatically will go. Okay, so this is the answer, NCR. This is the solution, you can see. Let's see the next question. Let's see this question. Try this. In this question he is saying that assume that 9 faculty members are there in the mathematics department, 11 faculty members are in the computer science department. You want to make a committee of discrete mathematics course. In this committee 3 faculty must be there. 3 faculty must be from mathematics and 4 faculty must be from computer science. So how many committee you can make? Try this question. So let's see. In this question what he is saying there is a mathematics department. In this mathematics department you have 9 faculty. There is a computer science department. In this computer science department you have 11 faculty. He is saying that How many ways are there to select a committee? He want to make a committee of discrete mathematics course. So they want to make a committee. They want to make a committee. Okay, whatever committee, whatever. So this committee they want to make, and in this committee they are saying that 3 faculty members from mathematics department. So from this mathematics department you need 3 faculty. From this computer science department, and from this computer science department you need 4 faculty. See, from this mathematics department you need 3 faculty, and from this computer science department you need 4 faculty. So how many committee are there? Very easily you can select. So from 9 faculty you need to select 3 faculty. How many ways are there? 9C3. Remember, this is AND, so product rule says that multiplication. This is AND means multiplication. Product rule, remember that product rule, because of AND this multiplication will come. Out of 11 faculty you need to select 4 faculty. From these 11 you need to select 4. From these 9 you need to select 3. So this will be your answer. So these many committees you can make. Neelam, it won't be plus, it will be multiplication. See, you need to do this and you need to do this. See, in the question he is saying like this: you need to select 3 faculty from mathematics and you need to select 4 faculties from computer science. So you need to do both things. Okay, you need to do both things. So this is product rule, because there is AND here. You need to do both tasks. You need to do task 1 and you need to do task 2. Okay, so because of this AND, this multiplication is coming. We have already seen this in the product rule. The product rule, summation rule, subtraction rule, division rule. We did a lot of practice for product rule also, like 4 or 5 questions we solved. So this is the solution, you can refer it. Okay, so let's see binomial theorem. Is the binomial theorem in the syllabus? Let me know. Is the binomial theorem in the syllabus, like in the UGC net? Because in the syllabus I did not find it. So before looking at binomial theorem, let's see this question. So okay, only a few things are remaining. So let's do one thing. We will cover these things in our next class. Okay, only few things are remaining in the combinatorics. The combinatorics is almost over. Only 5 or 6 slides are remaining. Okay, so we will cover it in the tonight we have a class. Okay, I think tonight from 9 onwards we have a class. From 9:30 to 11:30 we have a class. In that class we will complete this combinatorics. Almost combinatorics is over, and we will start probability. Okay, so if anyone has any doubt, then you can ask right now. Anyone has any doubt? Any doubt? Anyone? If anyone has any doubt, then you can ask. Okay, then I think no one has any doubt. So okay, see you tonight. We will start probability tonight. Okay.